Right, so the fifth method used to solving the differentiation problem is called implicit differentiation. And now, what is this implicit differentiation? This is unlike other differentiation problems where you can easily differentiate and get your answer. This one has to do with two different variables. You get, but let's quickly get into it. So let's assume you are given a function. Let's say y is equal to, let's say s cubed plus y cubed equals to 6x. This is an example of an implicit question. Because so now this implicit question has to do with, as I said, it has to do with two variables. Understand? But what about this one is after differentiating y, you are not differentiating y, you now put the y over the x. That's simply what. Or that's simply what distinguishes this one from the other ones. Because let's say in this problem now, after differentiating x, after differentiating x, you write down the answer. But if you differentiate y, you now put the y over the x. So whereby at the end, you now bring out the y over the x one side and carry the other one to the other side, and that becomes your answer. You understand? Let's say given this question here, let's say find the y over dx. Yeah, so now, from here, I said the y, okay, find the y by the x. This is what I have to find. Now, like I said, in implicit differentiation, if you differentiate x, the answer will be like that. But if you differentiate y, you now, after differentiating the y, you now put the y over the x. So now, if you differentiate s cubed from our normal power rule, bring down the power, which is 3, multiply the base, and reduce the power by 1, which is 3x squared, right? Plus, now this is the same thing, differentiate this one also, 3y squared dy over dx. This is all the difference. After differentiating the y, we now put what? Dy over dx. That's just it. So equal to 6xy. This one now has to do with what? It has to do with product rule. Remember, this is done together. Product has to do with two things being joined together. This is going to use product rule method to solve it. Okay, so product rule, let's assume this is u and assume this is v. Right? So if I say if I keep this one constant, I'll retain this one. If I keep this one constant, I'll retain this one, right? So this will give me 6x. I'm keeping this one constant. So to differentiate y now, I have what? dy over dx. Remember, if I integrate y, if you differentiate the variable, you have what? 1. So, but since 1 is like if y over the x is simply 1 divided by the x. So when you're putting 1, I'll just say dy over the x here. You get then plus. Now keep this y constant. Keep this y constant. Differentiate this x. You have 6. You understand? So if you now do it, you have 3x squared plus 3y squared dy over dx equals 6x dy over dx plus what? 6y. So now after doing it, take anything that do with dy over the x to the left hand side and the other one to the right hand side. So now this one we have to come over to this side. So I'm having 3y squared dy over dx, right, minus 6x dy over dx equal to 6y minus what? 3y. Okay, minus what? 3x squared. That's 3x squared. So now factorize this. What is common between this and this? I think 3 is common. Okay, let me bring that dy by x one side first. Bring that dy by x. Since it's in two of them, so what will be left? 3y squared minus what? 6x equal to 6y minus 3x squared. So now I can, since I want to get the y over the x, I can easily what? Divide by what? The coefficient, which is this. 3y squared and 6x. Whatever I do here, I also do it here. 3y squared minus 6x. So this cancels this. If I'm having that by what? My divide by the x equals 6y minus 3x squared over 3y squared minus 6x. Now this is the answer, but I can do something else. Since 3 is a factor of 3 and 6, and that is applicable to the what? Numerator, I can say, therefore, dy over the x equals, if I did not 3 here, if I did not 3 outside, I want the x inside. I'll have y minus what? Here I'll have, okay, 2y minus x squared, right? 2 minus x squared. Then over, I have 3 here, and 3 is a factor of 3 and 6. So I'm bringing out 3 again. So I'll have y squared minus what? Minus 2x. Right? So this, whereby this times is 6y. This times is minus 3x squared. This times is 3y squared. And then 3 times minus 2x give you what? Minus 6x. So since this and this are out for the y over the x equals 2y minus x squared over y squared minus 2. So this is just the difference between this one and normal differentiation. So thank you. Alright, then one of my students asked a very brilliant question. He said, how do I differentiate with 6xy? So give me this. So I recall, or this 6xy can also be represented as 6x. Whereby if you use this and multiply this, you still get back this, right? So now, using product, what is saying, keep this one constant, differentiate this one, plus keep this one constant, differentiate this one, right? So now, if I'm keeping x constant, and if I keep x constant, I want to differentiate y, I want to what? 1. But since I'm talking about implicit differentiation, it's going to be 1 dy over dx. So this is 1 dy over dx. You get. Then plus, keep y constant, which is y. Now differentiate what? X. If you get x, you have what? You have 1. And this is dot 1. You understand? So if you now close it, remember that there is 6 here. If you put it back, I will have what? 6x. This is 1 dy dx, which is dy over dx. Plus 6. This y times 1 is what? 1. So 6 times y is what? 6y. So this is how you're able to do this. I hope you understand now. Thank you. Please, if you find this video interesting, please do well to subscribe. Click on the red button. Subscribe, follow, like, and please, if you have any questions, please do well to drop your question in the comment section. And please share to your friends, share to your family, share to everybody you love, because this is the easiest way you can learn calculus. Thank you, and God bless you.